All right, we're going to get started on day 5, and this is on page 17 of your notes. And we're talking about solving systems by elimination. So this is the next method of algebraically solving these systems. And we start with a situation here where 3 friends go and buy some food, and one of them finds a table. And so, they kind of buy food as a group. And one of them is charged $10.50 for 4 slices of pizza and 1 large drink. And the other is charged $7.50 for 2 slices of pizza and 2 large drinks. And so what we end up with is this system of equations, right? So 4p plus d equals 1050, and 2p plus 2d equals 750. That's what we get from this situation. All right, and so we'll notice that the p and the d, what would these represent? Well, if the 1050 and the 750 over here, these are dollar values, right? These are amount values. And the coefficients, the 4 represents the slices of pizza, right? So 4 is like the number of slices. So we have the number of slices, and then we have dollar amounts over here. So these variables have to be represented in dollars so that we can end up with dollars. And so we want to be specific here. P is the price of 1 slice of pizza. And that's why in that first equation it's being multiplied by 4, because there's 4 slices. And then D is the price of 1 drink. Okay. So Conrad, the person who had the first equation, right, who got the 4 slices and a drink for $10.50, he claims that 8 slices of pizza and 2 drinks would cost $21. Is he right? And how do you know? So I would like you guys to actually go ahead and pause the video and just think about that. All right, so knowing what he bought 4 slices and 1 drink, and it cost him $10.50. And so his idea is that if he would have gotten 8 slices and 2 drinks, it would have cost him $21. And so is he right? So the answer here is going to be yes. He is correct, because he doubled his order. Right? If you get 4 slices and 1 drink, 4 slices and 1 drink, half that, right? And it costs him $10.50. Then if you just double the amount you get, you should double the amount that it costs. So that would be correct. Okay. Andrea claims that 6 slices of pizza and 3 drinks would cost $18. Is she right? How do you know? So again, let's pause the video, think about that, see if you can come up with an answer. All right, so hopefully you found some information that would lead you to answer this question. 6 slices of pizza and 3 drinks would cost $18. Well, what did Andrea get? Andrea got 2 slices and 2 drinks and paid $7.50. And Conrad had 4 slices and 1 drink and spent $10.50. So if we think about the amount of food that they bring back to the table, let's say, how much total food do they bring back to the table? Well, Conrad's bringing 4 slices and Andrew's bringing 2 slices. So that would be 6 slices of pizza. And Conrad's got 1 drink and she's got 2 drinks, and so that's the 3 drinks. And he spent $10.50, she spent $7.50, and that's a total of $18. So is she correct? Well, yes. What did we do there? That is adding the total cost of the 2 equations. It's putting the situations together. So we can say that she added the total food and drink and total cost. Right, she added it all together, and so that would make sense. Okay, so Jenna, the person who's actually trying to pay her friends back for the cost of food, did not find either of those results useful because she kind of needs to know how much 1 slice of pizza would cost and how much 1 drink would cost, like individually. She did figure that one of each, a slice of pizza and a drink, would cost $3.75. So she could solve the problem by solving this system. So she's changed the second equation. Is she correct, and how do we know? So she has gotten this new equation: 1 pizza, or 1 slice, and 1 drink for $3.75. And if we look back up at the original, it was 2 slices and 2 drinks for $7.50. So is she correct in her reasoning that 1 slice and 1 drink would be $3.75? Yes, she is, because that would just be half of her order. So this is half of the second equation. Okay, so now looking at this new system, Andrea figures that 3 slices of pizza would have to cost $6.75. And she wrote the equation 3p equals 6.75. Is she right? How do you know? Okay, so where would she have come up with just 3 slices of pizza? Well, if we look at the difference between, let me erase this. So if we look at the difference between these equations, what do we notice? The first one is 4 slices and 1 drink, and the next one is 1 slice and 1 drink. Because both of these have 1 drink in them, then the real difference in this equation is that the first one has 3 extra slices of pizza, right? And how much extra money did that first one cost? $6.75. And so yes, this is correct. And what we're doing here is we're essentially subtracting equations. Right? We're taking this 4p plus d equals 1050, and we are subtracting this whole thing right, and we're subtracting it. We get 3p, d minus d, that's gone, there's nothing there, that's 0, and then this is 675, and so that's how we end up with this equation there. So based on the reasoning, what do you think they calculated for a cost of 1 slice of pizza? Well, we would just continue to solve this by dividing by 3, and I believe that comes out to be $2.20. $2.25. So there's the cost of a slice of pizza. How about for a large drink? Well, if I go back to one of my equations here, I know that one slice and one drink is $3.75. And I now know my slice is $2.25, so I'll just put that in for P. And now I can solve this equation. So just subtract the $2.25. And I end up with D equals, what is that? $1.50. Okay, and so we have solved the system of equations. Now, last class we talked about how the solution to a system of equations is a coordinate point, x comma y. In this case, it's not a coordinate point because we're not using x and y. We're using actual variables, like something that actually represents something. And so in these type of questions, especially with word problems, if it's a word problem and we're answering systems, we should answer it in words. So, we would say one slice costs $2.25 and one drink costs $1.50. Right? Because we can't put x and y because we don't know which one is, there's no like independent or dependent variable here. So we don't relate them as a coordinate point. So this is the idea of the elimination method. The things we just talked about. We can multiply equations, right? We doubled it, or we took an equation and cut it in half. So we can multiply equations by values. We can subtract equations. We can add equations. And that's what we do for elimination. In order to eliminate a variable, they have to have the same coefficient, and then we can subtract it. I like to distribute this negative sign to everything and then subtract. Okay, because sometimes it gets confusing with the signs, so we have to be very careful with the signs. So I like to distribute the negative and then combine the equations. So I talk about combining the equations. I just combine the variables that I see, and I don't have to worry about the operation at all. So if it's a negative, I just use it as negative, and if it's positive, I add it. Okay, so here's the example. Next page. We're going to solve this equation by elimination. Now, this is an equation that is not a word problem. It's just an x and a y. And so when we do solve this, we can end up writing a coordinate point. So if we look at the first step, we have to make sure that the terms are all lined up like this, right? So the y terms are lined up vertically, x terms are lined up vertically, and then the constants, the numbers, are over here vertically. So line everything up vertically. Next is we're going to set this up for elimination. So right now, if I tried to eliminate the y variable, I would have 2y and a 3y. And if I combine that, I get 5y. That hasn't eliminated it. If I subtract it, I get negative y. Okay, so we have to get the same coefficient. So my rule is, the easiest way to remember this is to multiply by the opposite coefficient and make one negative. So multiply by opposite coefficient and make one negative. Okay, so right now, both y's are positive. If both y's were negative, I wouldn't have to worry about making one negative because one's already negative. So both y's are positive, and I'm going to multiply by the opposite coefficient. So the top is going to get multiplied by 3. The bottom is going to get multiplied by 2. And I'm going to make one negative. So I'm going to make that negative 2. When I do that, I distribute that to all 3 pieces. So all 3 terms. So I get 6y minus 18x equals 30. Right, I just distributed this 3 and multiplied it to all 3 terms. Now I'm going to distribute the negative 2 to all 3 of these terms, and I get negative 6y plus 6x equals negative 90. And then the next step is to add or subtract. This is where I just say combine the 2 equations together vertically. So 6y, negative 6y, that's what's been eliminated. There's nothing there left. The negative 18x plus 6x. Right, so now I'm just looking at the x terms, making sure I take the sign in front. And that would be negative 12x. Right, I get negative 12x there. I'd have 0 here. And 30 minus 90 is negative 60. And so this is the equation I end up with. And I just have to solve that resulting equation. So I would take that and divide by negative 12. And I see that x equals 5. But just like last class, right, once I find x, I now have to figure out what my y value is. So I plug that back into one of my equations. I'll just go ahead and take the first one. So 2y minus 6x equals 10. So 2y minus 6x equals 10. I know x is 5, so I plug that in for x. And I see that 2y minus 30 equals 10. So I add 30. And then 2y equals 40. Divide by 2. And I see that y equals 20. To check the solution, we would make sure that it works for both equations. So our solution here, 5, 20, we would check by plugging in. So 2y minus 6x equals 10. And the other equation was 3y minus 3x equals 45. And I check both these equations. So here's my x and y. So I plug them in. The y is 20. X is 5. I'll just plug it all in at once. And I make sure I get a true statement on both of these. This is 40 minus 30 equals 10. That's correct. 60 minus 15 equals 45. That is also correct. So this is our correct solution. That would be the intersection point of these two lines. And it is the solution to the system of equations. So that is solving by elimination. Okay? So you guys have some practice here. You guys can start working on this practice. Solving using elimination. Number 3 on the next page goes into the three different methods of solving. So substitution, elimination, and graphing. And so we would want to solve this same system, the three different methods. So keeping in mind you should get the same solution each time, but it's just doing it in a different way. Okay, so you guys can pause the video, practice questions 1 and 2 right now, and then unpause, and I will work it out as well so that you can see and check your answer. All right? Okay, so for number 1, I said that you should multiply by the opposite coefficient and make one negative. So I'm just going to go ahead and do that. So I'm going to multiply the top one by 3 and the bottom one by -5. Opposite coefficient, make one negative. So that's 15x plus 6y equals 3 times 12 will be 36. And then negative 15x plus 10y, careful with the negative times negative there, equals negative 20. And then combine them. So that's eliminated. 15x minus 15x is gone. 6y and positive 10y makes 16y positive. 36 and a negative 20 would make a positive 16. So 16y equals 16, divide by 16, and y equals 1. Plug that into one of the equations. Oops. And so our answer here would be 2, 1. All right, number 2, if you haven't done that yet, pause, and now I will go over the answer. So let's multiply by 2 and -3. So 6x plus 14y equals 4. Negative 6x minus 9y equals -9. Combine, that's gone. 14y, negative 9y, so 14y minus 9y is 5y. 4 minus 9 is -5. And divide by 5. Y equals -1. So plugging that in, to solve for x, x equals 3. And so there's our answer to number 2. All right, moving on to number 3. So that's one system that we're going to solve in the 3 different ways. And then same thing in number 4, just a different system, but we solve it in the 3 different ways. Okay, so I'll leave number 4 for you guys to do on your own, and we can kind of maybe go over that at the beginning of the next class as well. Once you guys are finished with this, you guys should be working on your homework for the day. So taking that out, and it would be 2.15. No, 2.14, sorry. Would be 2.14. So after this, remember homework 2.14. Okay. So let's solve this by substitution. If you remember from last class, substitution means get one of the variables by itself. The easiest variable to get by itself is the one without the coefficient, so that's going to be this first y. So I'll subtract the 2x, and I get y equals 3 minus 2x. And so I'm going to take that and plug it in for the y in the next equation. And combining like terms and solving here. Okay, I get x equals 1. I'm going to go back and plug that in over here. And excuse me, I'm getting y equals 1. Whoops. So 1, 1 is the coordinate point. So that's substitution. Got one variable by itself, substituted it in, solved, plugged in, found the other variable. Now for elimination, 2x plus y equals 3, and 4x minus 3y equals 1. I'm going to keep it like this because they're already lined up vertically, which is what I need. And so you multiply by opposite coefficient, making one negative. So that'll give me 8x plus 4y equals 12, and negative 8x plus 6y equals negative 2. Combining these, that's eliminated. 10y equals 10. And so y equals 1. Plugging that in. We see that x is equal to 1. So we get the same solution point, which is good because it's the same set of equations. It's just the different methods. So now for graphing, remember to graph you have to get y by itself on both. I believe we already got y by itself in substitution up here. Y equals 3 minus 2x. That's just going to save me some time. I'm going to remember that. 3 minus 2x. And now we have to solve the other one for y as well. So I'm going to graph this. And then I'm going to graph whatever I get down here when I get y by itself. So make sure you guys try that before I do. So you should be pausing when you need to. Don't forget on this step you're going to divide every term here by negative 3. And so y equals negative 1/3 plus 4/3 x. So we're going to go ahead and graph that. So this graphing, because there's fractions, right, y-intercept of negative 1/3, I'm not just going to eyeball that on the y-intercept. Instead, I'm going to plug that into the calculator, into y equals. look at the table and plot nice points, right? Whole number points. That'll make it a lot easier. This one I can graph by hand because it has a y-intercept of 3 and it has a slope of -2, so down 2, right 1. Oops, that didn't come out very good. It's kind of hard to draw a long straight line on this thing. That worked. All right, that is y equals 3 minus 2x. This one, again, we're going to plug in to y equals, find nice points, and plot them. When you look at the table, one of the points you should see is 1, 1. And it has a slope of 4/3, so that's up 4 over 3. Up 4 over 3. And that continues in both directions. And that's y equals -1/3 plus 4/3 x. So remember to label your lines because we have more than one on the same graph. And there's our intersection point at 1, 1, which is our solution to the system. All right, so there's another practice problem down here. In this one, remember substitution. Get the easiest variable by itself first. And remember for elimination to line up your variables vertically. So if you notice, 2x and 4x are lined up, but then the other things are not lined up. So we want to rearrange this one for elimination so that it's lined up this way. So I want the y on the other side of the equation. And so I would just subtract the y to the other side for elimination. Right, just subtract that y from the other side, because then you have 4x minus y equals 10. And now you can line that up vertically with the 2x plus 3y equals 12. All right. So you guys can go ahead and finish these pages, this note page, and then work on your homework. And that's about it for today. And again, I apologize, I can't be there in person today, but if you do have questions and would like to join a Google Meet so that we can talk and you can ask the questions, just let me know. Send me an email or whatever. Okay? Alrighty, so that's about it for today. And next class, you should have this page completed. Complete this page by next class. And then I will go over the answer next time. Okay? All right. That's it. I will see you guys later.